Hey, what's up? What's up? It is Wednesday, May 1st. Guess what? Guess what? Newsflash, newsflash. My birthday is tomorrow. What's up? Just kidding. Actually, not just kidding. Tomorrow is my birthday, so I'm actually excited. A little bit lightweight. Let's keep it going. Keep it going. So we're gonna be adding stuff to this journal check each day. This journal check's gonna end up being worth more than 30 points. I don't know what it's gonna be, but 40-ish, somewhere in there. So if you take a look over there, actually over there, sorry, boom, over there, then you'll see that we're increasing the entry activities, and then we're also adding on the things that we did yesterday. So the atom diagram, the electron shell, and that was carbon, and then also the different vocab words. So as we're adding things on, we will just add that. So just realize that, okay? Cool. Now, I do want to get here and say, because we talked about this yesterday, an atom is a very small particle that makes up all matter, and matter is made up of protons, neutrons, and electrons. Remember, protons are positive, electrons are negative, and then neutrons are neutral, okay? Protons positive, electrons negative, and then neutrons, they are neutral, okay? So let's get that. Then also, what is matter? Hopefully you got an answer. What is matter? So anything that takes up space and that has a mass or weight, right? And matter is made up of atoms. And this is why they've got that dad joke. And you know what it says about atoms? Check this out. It says the reason you can't trust them is because they make up everything. Just saying. Just saying. All right. Moving along. So we did draw this yesterday, and this is the carbon atom with the electron shells. And just as a reminder, in the nucleus is protons and neutrons. So protons and neutrons are here in the nucleus. Then you got these electrons floating around, these electron shells. Just as a reminder, we haven't got there yet, but just look at this. In this first electron shell, there's only two, and it's because that electron shell is small and only can fit the two electrons. That's what we're talking about. So this next electron shell is larger and more on the outside of it. So you got to think a shell within a shell within a shell, right? This kind of idea, and it fits more electrons. We'll talk about how many electrons it fits later. Just realize, like, the first shell fits two, and then the next proceeding shells all will fit more. And remember that this is a neutral atom. So since it has 6 protons, they're positive, as 6 electrons. They are negative, so they cancel each other out. So you end up with a charge of 0 because all the neutrons, they have no charge at all. Okay, cool. So we are not going to watch this video. We're going to skip right through that, and then we're going to ask this question is, why couldn't we find water on the periodic table yesterday? And hopefully you got the answer because it's the periodic table of elements. That's what you see right up there. Periodic table of elements, not of molecules. So water is a molecule, right? So it's a molecule. So because of that, it has more than one atom that is bonded together, and that is the definition of a molecule. So because of that, there's molecules, not molecules on the periodic table. It's the periodic table of elements. So it's the elements that make up the molecules. Okay. All right. Cool. Let's go here. I think this is where we stopped, and this is something that's mad important. I just want to make sure to go over this idea that, over here, you make sure that you can count. And I think I showed that on the board yesterday. Is this idea? It's like right there, okay? So we'll just look at that real quick. Is just that when we're counting, so there's 2 hydrogens, 2 plus, and there's 2 oxygens, plus 2. That means in total there are 4 atoms, okay? Again, 4 atoms, and that's how you add it. So this subscript number belongs to the element to the left of it. That's why I drew that arrow, because I thought that might be helpful for remembering purposes, okay? By the way, that H2O2, I think I mentioned it yesterday, but that is hydrogen peroxide, okay? Cool. Now, let's go ahead and move it along. Now, I'm going to get myself up out the way, and I'm going to say pause the video and try to fill in these 2 blanks. Again, try to fill in these 2 blanks. That's what you need to do. When I come back, I will be explaining, but for right now, just try and fill in the 2 blanks. What's up? Did you get that problem done? Or you was just trying to wait for me to explain? No, try and get the problem done, okay? Yeah, and then keep going. Okay, so let's just go ahead and look at this. Hopefully, you really tried. That's what I just need you to try. So a chemist draws 2 molecule models. So that's model 1 and model 2, right? One model is drawn from formaldehyde, and this is the chemical formula for formaldehyde. So I'm going to write that right here, CH2O, okay? CH2, and then there's an O. So one model is drawn from formic acid. So the other one's formic acid, so that's CH2, and then it says O2. So similar looking, right? But a little bit different. The chemist forgets to write the chemical name above each model. The models are labeled as model 1 and model 2. So let's just look at these, okay? So there is one carbon there. Okay, so I'm going to go at 1. There's 2 hydrogens here because of this right here. Boom, right? 2 hydrogens. So I'm going to say plus, and then plus the 1 oxygen. There's no subscript. That's going to end up with 4 atoms. Now, if you're able to do that, then you're going to be able to determine which one is formaldehyde off the top. So formaldehyde's this first one, right? So here's the deal. There's 4 atoms. So this one has 1, 2, 3, 4. So it must be that one. We're going to count the other one just to make sure. 1, 2, 3, 4, 5. So that lets us know that this one right here is formaldehyde. Cool. So that means this other one must already be this one. But we're just going to double check to make sure. So carbon has 1, plus hydrogen has 2, plus oxygen has 2, which is equal to 5 atoms. Okay? Cool. So now, with that being said, then let's look at this. 1, 2, 3, 4, 5. Okay. So that must mean that this one is that one. And so this one over here must be the acid, right? This is the acid. And then I'm just going to abbreviate here and say this is the 4. And I'm going to put period right there. Okay, so now we know who's who. So now, no matter what question they ask us, we can answer it, right? Like we've already identified. So if you're able to count the number of atoms in here and then count the number of atoms in the model, then regardless if you know what formaldehyde is or if you can even pronounce it, you should be able to count it and figure out who's who. So formic acid is represented by model number, and that would be model number 2, formic acid. So that's model number 2. The model has a different number of, and let's just look, different number of what kind of atoms. So carbon is 1 and 1, hydrogen is 2 and 2 down here, and then this one has 1 oxygen, this one has 2, so then it would be a different amount of oxygen atoms. Now, does that make sense how we kind of broke that down? All right, let's go to the next one. Let's go to the next one. Boom, boom, boom. Sauce. Okay. And we'll give you a couple minutes to do this one as well. Yo, did y'all get this done? Did y'all get this done? Or were you just waiting for me? Yeah, get it done. Get it done. Okay, let's try this. Okay, so here we have, if you read everything, it says there's several bottles with a vacuum lining, just as described, and then they have them in this data table, and they're trying to figure out which ones can do 2 different things. So here's the data table. It looks like they have some that are steel, and it looks like there's some that are glass. Steel, glass, and then they have different types of lining or insulating foam or something like that. That's what it says, right? So students are asked to make a claim which design will meet the 2 criteria. What are the 2 criteria? That's the important thing. The bottle must be break resistant and must keep the water water hot the longest. So then see which one does that. So let's just take a look. So which one do you guys think is going to be the one that's going to be the most break resistant? Most people said it's going to be the steel one. So the steel ones are going to be break resistant. So that's going to help for the break resistant. And they're going to say glass, that might be more likely to break. Okay. Then you're going to go to which one's going to keep it the hottest. And most people went with the ones that insulate the foam. So I'm like, okay, because they're like the foam keeps the heat or the cold in. So then it looks here like for number 3, it does a good job of being break resistant, but then also keeping cold or heat inside. So that's the one that we're going to go with. Now, when you're going to look at these answers, it's going to be more like this. Watch. It's going to look like this, and you're going to have answers to read from. And so it has a breakable, an unbreakable steel inner lining, and a foam cover that will keep the heat in for the longest time. That would be the claim that we're going to go with, okay? So just make sure that you read this, and once you've gotten to that place where you're like, oh, I could answer any question, that's how you want to be, because you have no idea what question they're going to ask. All right, let's go ahead and move on to this. So we'll talk about this, and you do need to take this note, okay? Actually, but before that, we're going to take a small break and try and do something. Okay, we'll see if you guys can do this. Now, I have my hand here. Every time I pass my hand, I just want you to clap. Yeah, that's right, like right now. So clap, 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 right? Clap, 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 clap. Okay, cool. Let's see if you guys can get it. Oh, okay. How do we do? How do we do? Did you guys get them all? Okay, let's try it again. Mm, 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 mm. Ooh. Oh, did you get it or did you clap? Let's see what happened. What happened? I don't know. Let's see. Because in class, they was not able to get it. They was not able to get it. We're going to try that one again. It's kind of hard to do because I don't hear you guys. You know what I mean? I don't know. Okay. So anyway. So this is the element made up of one atom, and it's made up of protons, neutrons, and electrons. So if there is one atom, right, just one atom, we call that an element, and it's made up of protons, neutrons, and electrons. By the way, which ones are positive? Hopefully you said protons. Which ones are neutral? Hopefully you said neutrons. Which ones are negative? Hopefully you said electrons. Okay, cool. So a molecule is a group of two or more atoms that are chemically bonded together. And they can be bonded to the same element, and I'll talk about that right now. Is right here, you have gold. They're bonded all to the same element, so it's a pure gold bar. Or you could have something like neon, which is also pure because it's just neon gas. It's neon gas bonded to other neon gas molecules to make up a bigger neon gas kind of cloud, right? Or here you have sodium chloride. So you have two different things. So sodium and chloride that are bonded together. So these are two totally different elements, but they are bonded together and they make this thing commonly known as salt. So it could also be that. So let's go there. Okay, let's move it along. So hopefully you got that. Again, an element is only one atom, and a molecule is two or more atoms bonded together. That's why we couldn't find water on the periodic table of elements. So they're one atoms. Okay, cool. Now, this is what I need you to do. This is going to be a little bit a lot. So we're not going to do this whole thing today. But what I need you to do today is this. So this right here, exactly what I did. So I got water. Got the chemical formula. Then right above, I wrote down, oh, they have two hydrogens, one oxygen, because it does not have a subscript here, so it's one oxygen, and it's three atoms total for the entire chemical formula. So what you need to do is you need to do that for all of these ones right here in the data table. You do not need to write down the names, but these ones over here, you do need to write these down. And this right here is hydrochloric acid. So hydrochloric acid, that lets me know it's hydrogen and chlorine. You will need your periodic table. We have not talked about all of these elements yet before, so you will need your periodic table to reveal what some of them are. But again, write down the chemical formula, then write down how many of each element there are in each one, and then the total number of atoms. If you can do this, this is the basics to doing so many things in chemistry. So that's why I'm like, hey, let me get you this skill, and this will help you when you are dealing with some of the things on the state test. All right, y'all. So again, write all these down. Right, you don't have to write the name, so write all these chemical formulas down, and then write how many of each element's in there, and then the total number of atoms. We will go over this tomorrow, first thing. All right, y'all. Peace.